Hello and welcome to the introduction for this course. What are the course requirements? You need a computer and internet connection to follow along with this course. Who is this course for? This course is for anyone who wants to learn something new. What is the course format? The format of the course is video. What is Azure? Azure is Microsoft's cloud computing platform. Azure has an expanding set of services to help you build solutions to meet your business goals. Azure supports infrastructure as a service, platform as a service, and software as a service. Azure supports virtual machines running in the cloud, website and database hosting, and advanced computing services like artificial intelligence and machine learning. Most of Azure services are pay-as-you-go, so you only pay for the computing time that you use. If your business needs complete control over your computing environment, Azure allows you to host virtual machines in the cloud. You can create virtual machines from scratch. You can upload your own virtual hard drive, or you can choose from an array of templates that Azure provides. Azure also provides cloud-based storage, which allows you to store your applications or back up your data safely and securely. Azure App Services provides a scalable hosting platform where developers can create web-based applications using popular development frameworks. With Azure, you can easily deploy, operate, and scale your apps in a fully managed environment. With Azure Functions, you can create event-driven serverless applications with no code required. Azure Container Instances and Azure Kubernetes Services allows you to deploy containerized applications with fully managed services. Azure offers a choice of fully managed relational and in-memory databases spanning from proprietary to open source engines. Microsoft Cosmos Database provides support for several NoSQL APIs. Azure Artificial Intelligence and Machine Learning Services empowers developers and data scientists with a wide range of productive experiences for building, for training, and for developing machine learning models faster. Azure Regional Data Centers allows you to distribute your applications globally so you can locate your data and apps where they are needed the most, thereby improving your application's performance for your customers. Azure Portal lets you create, configure, and control all your services and resources from a single, easy-to-use web-based interface. Azure offers a wide range of cloud computing services such as infrastructure management, scalability, availability, and security. These are all handled by Azure, saving you money and time. Hello and welcome to this video. In this video, I'll be showing you how to create a free Microsoft Azure account. To create a free Microsoft Azure account, you will already need to have an account on a Microsoft product, for example, Hotmail. If you haven't got one, you'll need to create one. Also, you need a credit or debit card for upgrade. So you will be requested to present your credit or debit card details. Microsoft does not actually charge you, but they just want the card on file just in case you need to upgrade and if you extend the free trial of the products. Here is the link to the Microsoft Azure website. This is the Microsoft Azure website. So if you look on the far right hand corner, there is a link here for free accounts. So if you click on that, it tells you by creating an account, you get free access for 12 months to some of the services So if I scroll down here, you can see what the free account gives you. So you have 12 months of popular free services, $200 credit, and there are some services that are free, but there are some services that has a cap on them. So once you exceed the free limit, you will be prompted to upgrade. Feel free to scroll down the page so you can see what the free account and also what services are available for the Azure account. So scroll through and then take a look. So once you are ready, there's an option here to start free. So just click on start free. You are presented with this Microsoft login account. So if you already have an account on a Microsoft product, this is where you enter the email address. If you don't have an account on a Microsoft product, there is a link here to create a new account. So I'm just going to enter my account details. So I've entered my account details here. I'm going to click next. Once you have signed in using your Microsoft account details, you can see your name will be displayed, and then you have this form you have to complete to create the free Azure account. So your region will be automatically detected here. Next, you need to complete the details of your profile form. If you look on the right here, it tells you what the create account entails. If you look here, it says no automatic charges. That means it will not charge you without letting you know. So after your credit is over on the service you are using, it will ask you if you want to continue as pay as you go. If you wish to do so, then the credit card that they have on file will be charged. They will not charge you without first asking you. The form also requires you to enter a phone number, so make sure you enter a valid number there, and then you have to check this I agree to the subscription. Make sure you check that. If you want to receive information or tips regarding Azure offers, you can leave that checked, but I don't want that, so I'm going to uncheck it. Also, if you like Microsoft to share your information, you can check that box. I don't want that, so I'm going to leave that unchecked. And then here you have to select the method of verification, either by phone or by card. So I'm going to click on this identification by phone, and then I'll click on the next button. Next, I can choose the option to send me a text or to call me. Once you get your verification code, make sure you enter your verification code here and then click to verify code. After the verification by phone, you also have to do the identity verification by card. So it tells you here that we'll make a temporary authorization on the card, but you won't get charged unless you upgrade. So obviously just enter your card details in here and then you click on the sign up button. Once your card has been verified, your account becomes active and you are redirected to the Azure page, and you may get this pop-up here if you would like to participate. For now, I'm going to say no. And then it tells you you are ready to start with Azure. Now that you have an account on Azure, to interact with any of the free products that Azure has, you have to do that through the Azure portal. So if you look here on the right here, there is the option for portal. That's where you need to go once you've logged in to interact with any of the Azure services. Hello and welcome to this video. In this video, I'll be showing you how to access Azure services. In order to access any of the Azure services, you have to log into the Azure portal. The link to log into the portal is displayed on the screen. Before you can log into the Azure portal, you should already have an account. If you haven't, you can click on this link here to create a new account. I have already got an account on Azure, so I'm going to click on this portal option here. it has detected that I have already logged in before. So I'm going to click on my username here. I've entered my password, so I'm going to click sign in. Once you have signed in to Azure portal, you can access the Azure services. So you have different links here to create a resource, SQL database, and so on. If you want to see more services, just click on this link here, and that will give you more services that you can look through. If you want to return to the home page, just click on the Microsoft Azure here on the bar, and that takes you back to the home page where you can navigate the page and then go through the different services and then click on the link to the one that you are interested in. In this video, I showed you how to log into the Azure portal in order to access the Azure services that are of interest to you. So that's it for this video. Thank you for watching. Bye for now. Hello and welcome to this lecture. What is NoSQL? Basically, a NoSQL database is a kind of hash table. A hash table is a data structure used to implement a type of associative array, which is a structure that can map keys to values. NoSQL are faster than a traditional database due to their fast lookup tables. All right, so they got fast lookup, so they're much faster than a traditional relational database. They don't have a fixed schema. The schema can be dynamic, unlike a traditional database where you have to define the schema before you use it. With a NoSQL database, the schema is dynamic and can be defined at execution. Another characteristics of NoSQL databases is that they do not use SQL to query data. They use JSON to query data. The data in NoSQL databases can be semi-structured or unstructured compared to the traditional databases where the data is structured and ordered in tables. Let's take a look at some differences between a NoSQL databases that does not use SQL to query data and a traditional relational database that uses SQL to query data. So these are some of the differences between a traditional database that uses SQL to query data and a NoSQL database that uses things like JSON to query data. So with a traditional database, the model type is relational. NoSQL is non-relational. Traditional databases deals with small to medium data sets, while NoSQL databases can handle large data sets. With traditional databases, it is schema based. The schema has to be predefined before it can be used. With NoSQL databases, the schema is kind of like dynamic, almost schemaless. So it's defined when at execution level. So it's almost schemaless and dynamic. With scalability, you can scale the traditional databases vertically and you can scale the NoSQL databases horizontally. The traditional database uses the International Structured Query Language known as SQL, also pronounced as SQL. It uses that to query data, while NoSQL databases can use JSON to query data. Traditional databases can use table joins to build complex SQL queries. NoSQL databases does not require any table joins. The support for traditional databases is great because it's been around for quite a while.
so it's quite a robust support available, while the support for NoSQL databases is still maturing. It's kind of like community-based support at the moment. The traditional database is not as flexible because the schema is rigid and strict. It has to be defined before it can be used, while the NoSQL databases has a more flexible dynamic schema. With traditional databases, you need to take the database down for maintenance if you want to do maintenance and stuff, while the NoSQL databases, you don't necessarily have to take the database down and there is no outage, so it's kind of like automatic. The traditional database uses the ACID acronym for transaction. You can look up that word. If you just type in ACID transaction in Google, it'll tell you what it means. It's an acronym, so the A, the C, the I, and the D, they mean different words. So, but it's beyond the scope of this lecture to explain it to you. But you can do a Google search on it; it will explain it better. And the NoSQL databases uses the CAP theorem type of transaction. Although it's work in progress, so this can vary in some instances of NoSQL databases. The current state of the traditional databases is that it is mature, it's been around for a while, and kind of like robust. The NoSQL databases is still emerging, it's an emerging technology, and it's still growing. The data structure for traditional databases is kind of like it's a structured format, and the data is stored in tables and well organized. In terms of NoSQL databases, the data is either unstructured or semi-structured, and data is stored in JSON. Examples of traditional databases include Oracle, Microsoft SQL Server, MySQL. There's a lot more, but these are just a few. Examples of NoSQL databases include MongoDB, Cassandra, HBase, and CouchDB. This is just a quick illustration of the data models for the relational database and the NoSQL database. So the NoSQL database largely has the document data model, while the traditional one has a relational data model. This model is non-relational, while this one is relational. So you can see the data is stored in tables, while for NoSQL is stored in JSON objects. All right. It is also estimated that by 2018, the NoSQL market would have grown to about 14 billion. That's it for this lecture. Thank you so much for watching. Take care and bye for now. Hello and welcome to this lecture. There are different types or flavors of the NoSQL databases. Not all of them operate under the same principles. In this lecture, we are going to look at some of the broad categories of the NoSQL databases. We'll start with the document store. This type of database stores its data in a structured format such as XML or JSON. The documents are usually organized in collections or databases. By doing it this way, it allows you to group similar documents all together. Individual documents can have unique structures, so you don't have to have the same fields in each document. Each document usually has a specific key This allows you to retrieve the document quickly. Also, it is possible to query a document by the specific fields contained inside. The next category is the key value store. Typically, you have a key you can query by, and then you have the value to that key. The only disadvantage or drawback with this type of NoSQL database is that you can only usually query by the key. You can't query by anything else. However, you can get around this because some of the databases allow you to define more than one key. So by defining more than one key, you can use that to probably get around the disadvantage. The key value store are sometimes used alongside relational databases to help in caching. So let's have a look at the next type or category. The next type we're going to talk about is big table or tabular databases. Big table is named after Google's own implementation of the big table. Each row in a tabular database can have a different set of columns. They are also referred to as tables with wide column stores. What that means is that they are designed to accommodate large columns. The rows in a tabular database are usually versioned. That means they've got version numbers. The next type or category we're going to talk about is the graph databases. Basically, graph databases is a database that uses graph structures for semantic queries, using nodes, edges, and also using the properties to represent and store data. Also, the graph databases are designed for data that is best represented by interconnected nodes. A typical example is a series of road intersections. The next type we've got is the object databases. The object databases are tightly integrated with object-oriented programming languages. The object databases act as a persistent layer and stores objects directly. What that means is that you can store the objects from your programming language directly into the object database. You can also link objects together through pointers. In this course, we are going to be using the document database to illustrate the concept of the NoSQL databases. So that's it for this lecture on the types of NoSQL databases. Thank you for watching, and bye for now. One more quick thing before I wrap up this lecture. Just wanted to show you just an illustration of the some of the types or categories of NoSQL databases that I mentioned in the lecture. So this is just a simple illustration showing the increasing complexity of the types of NoSQL databases. So you start with the key value store, and examples here is Redis or React, and then we've got the wide column store, which you have Apache HBase, you've got Cassandra, And then you've got the document store, which includes examples of MongoDB and CouchDB. We are going to be using CouchDB for the duration of this lecture, of this course, sorry. And then you've got the graph store, and this gives you an example of who uses the graph store type of NoSQL databases. And this is the increasing complexity of the types of NoSQL databases. So that's it. Thanks for watching. Hello and welcome to this lecture. What NoSQL can do. There's a lot of possibilities where you can implement NoSQL to make life a lot easier for your database solutions. For example, many NoSQL databases can be used to easily create web applications with customizable fields. With NoSQL databases, you don't really have to worry about a schema if there's any schema changes, and you can use index. You can use index in the fields. For an example, if you have an application that keeps track of comments on articles, you can add things on the fly. For example, you can add votes, things like votes later. Another possibility of the NoSQL database is that it can be used as a caching layer. This is useful when used alongside a traditional database. You can use that to keep traffic away from the traditional database. And you can do this by writing code that will pull data away from relational database and then store the data inside the NoSQL database. Then you can use NoSQL for your API to access the data. Many NoSQL databases can also store binary files. With NoSQL databases, you really don't need to worry about file system permissions. NoSQL databases frequently will extract all the metadata about a file. Metadata basically is information about data. So the NoSQL databases can extract all the metadata about a file and allow you to query by it. So it allows you to query using that metadata information. You can also use NoSQL database to attach other data to specific files. NoSQL databases also allow you to serve full web applications. So things like your HTML, your CSS and JavaScript can be served directly from NoSQL. You can use the permissions you have in NoSQL to control who can read and write data. You can also use NoSQL databases to build new applications completely from scratch. So these are some of the things you can do using NoSQL. This is just an illustration or a sample of what the possibilities of NoSQL databases are. There's a lot more you can do with it. This is just kind of like a drop in the ocean of what NoSQL databases can do. So that's it for this lecture. Thanks for watching. Bye for now. Hello and welcome. In this video, I'm going to highlight some of the key differences between a relational database and a NoSQL database. A NoSQL database has horizontal scaling, while a relational database has vertical scaling. By horizontal, basically what that means is that you can add more machines to the pool of resources you already have, while a vertical scaling basically means you just add more resources to the existing machine you have, like add more memory or add more CPU power. With a NoSQL database, the design is simpler in comparison to a relational database. With a NoSQL database, it's usually high availability. What that means is that the resources has to be able to be available 24 hours a day and usually 365 days a year. In comparison, relational databases are not as robust. The data structure in NoSQL databases make them much more faster in comparison to a relational database. With a NoSQL database, the structure is usually decentralized, while a relational database has a more centralized structure. In a NoSQL database, it supports a read-write scalability, while the relational database only supports a read scalability. With a NoSQL database, the data can come from a variety of locations, while in a relational database, the data is usually from one or fewer locations. The NoSQL database supports very simple query language, while relational databases supports a powerful query language like SQL. The schema in a NoSQL database is flexible, while a relational database schema is fixed. NoSQL databases deals with high velocity data in comparison to relational databases that deals with low velocity data. By velocity, I mean the speed at which the data is being processed. NoSQL databases can handle unstructured and semi-structured data, while relational databases only handle structured data. With a NoSQL database, there is no single point of failure because it is decentralized, whereas in a relational databases, there is a single point of failure due to its centralized nature. NoSQL databases deals with a large volumes of data, while relational databases deals with moderate volumes of data. Let's take a look at the key difference between a typical relational database management system like Oracle or MySQL and Cassandra. With a Cassandra database, the data is unstructured because it's a NoSQL database, whereas relational database has structured data. With Cassandra, the schema is flexible. Again, relational databases deals with a fixed schema. Cassandra, the table is a list of nested key value pairs. That is rows times column key, and then you have the column key value. Whereas in a relational database, the table is basically an array of arrays, that is row times the columns. In Cassandra, the data is held in key spaces, where in relational database, the data is held in a database. In Cassandra, relationships are represented by using collections, while in relational database management system, you represent relationship using foreign keys and table joins. In Cassandra, a row is a unit of replication, while in relational database, a row is an individual record.
Hello and welcome to this video. What is Azure Cosmos DB? Azure Cosmos DB is a fully managed NoSQL database for modern app development. Azure Cosmos DB takes database administration off your hands with automatic management, updates, and patching. Azure Cosmos DB also handles capacity management with cost-effective serverless and automatic scaling options that responds to applications' needs to match capacity with the demand. Let's take a look at some key benefits of Azure Cosmos DB. Azure Cosmos DB guarantees speed at any scale. Azure Cosmos DB enables real-time access with fast read and write latencies globally, and throughput and consistency, all backed by service level agreements. It also allows multi-region writes and data distribution to any region with the click of a button. It also independently and elastically scales storage and throughput across any Azure region, even during unpredictable traffic outbursts. Azure Cosmos DB allows for simplified application development, so you can build fast applications using open source APIs, multi SDKs, schemaless data, and also no ETL analytics over operational data. You can deeply integrate with key Azure services used in modern cloud-native application development, including Azure Functions, Internet of Things hubs, Azure Kubernetes Service, App Service, and more. Azure Cosmos DB has multiple database APIs that you can choose from, like Core SQL API, API for MongoDB, Cassandra API, Gremlin API, and Table API. You can build apps on Core SQL APIs using the languages of your choice with various SDKs, for example, .NET, Java, Node.js, and Python, or your choice of drivers for any other database APIs. Also, change feed makes it easy to track and manage changes to database containers, and also to create triggered events with Azure Functions. Azure Cosmos DB's schemaless service automatically indexes all your data, regardless of the data model, to deliver blazing fast queries. Azure Cosmos DB is mission critical ready, so it guarantees business continuity, 99.999% availability, and enterprise level security for every application. Azure Cosmos DB offers a comprehensive suite of service level agreements, including industry leading availability worldwide. It easily distributes data to any Azure region with automatic data replication. It also enjoys a zero downtime with multi-region writes or RPO zeros when using strong consistency. It allows you to enjoy enterprise-grade encryption at rest with self-managed keys. The Azure role-based access control keeps your data safe and offers fine-tuned control. Azure Cosmos DB is fully managed and cost-effective. It allows end-to-end database management with serverless and automatic scaling. The database service is fully managed. It is automatic, no-touch maintenance, patching, and updates. All these are done automatically, thereby saving developers time and money. It has a cost-effective option for unpredictable or sporadic workloads of any size or scale, enabling developers to get started easily without having to plan or manage capacity. Its serverless model offers spiky workloads, automatic and responsive service that is used to manage traffic outburst on demand. It uses autoscale to provision throughput automatically and instantly can scale capacity for unpredictable workloads while maintaining the service level agreements. Azure Synapse Link for Azure Cosmos DB is a cloud-native hybrid transactional and analytical processing capability that enables a near real-time analytics over operational data in Azure Cosmos DB. The Azure Synapse Link creates a tight, seamless integration between Azure Cosmos DB and Azure Synapse Analytics. It reduces analytics complexity with no ETL jobs to manage. It has a near real-time insights into your operational data. It has no impact on operational workloads. It is optimized for large-scale analytic workloads. It is cost-effective. It has analytics that is locally available and globally distributed across multi-region rights. It uses native integration with Azure Synapse Analytics. Hello and welcome to this video. In this video, I'm going to explore the APIs available within Azure Cosmos DB. What is an API? An API stands for Application Programming Interface, which is a set of definitions and protocols used for building and integrating application software. APIs are a mechanism that enables two software components to communicate with each other using a set of definitions and protocols. An example of an API can be a weather software system that contains daily weather data. The weather app on your phone can talk or communicate with this system using an API which shows you the daily weather updates on your phone. So using an API, software systems can communicate with each other using different types of devices. Azure Cosmos DB offers multiple database APIs, which includes Core SQL API, API for MongoDB, Cassandra API, Gremlin API, and Table API. These are the APIs available within the Cosmos DB. By using these APIs, you can model real-world data using documents, key values, graph, and column family data models. These APIs allows your application to treat the Azure Cosmos DB as if it were various other database technologies without the overhead of management and scaling approaches. Using these APIs, Azure Cosmos DB helps you to use the ecosystems, tools, and skills you already have for data modeling and querying. All these Cosmos DB APIs offers automatic scaling of storage and throughput, flexibility and performance guarantees. The Core SQL API stores data in document format. It offers the best end-to-end experience as we have full control over the interface, the service, and the SDK client libraries. Any new features that is rolled out to the Azure Cosmos DB is first available on the SQL API accounts. The Azure Cosmos DB SQL API accounts provide support for querying items using the structured query language syntax, which is one of the most familiar and popular query languages to query JSON objects. SQL API supports analytics and offers performance isolation between operational and analytical workloads. The API for MongoDB stores data in document structure via the BSON format. This API is compatible with MongoDB wire protocol. However, it does not use any native MongoDB related code. You can use your existing MongoDB apps with API for MongoDB by just changing the connection string. You can move any existing data using native MongoDB tools such as MongoDump and MongoStore, or you can use any Azure database migration tool. Tools such as the MongoDB Shell, the MongoDB Compass, and the Robo3T can run queries and work with data as they do in the native MongoDB. This API is a great choice if you want to use the broader MongoDB ecosystem and the skills you already have without compromising on using the Azure Cosmos DB features such as scaling, high availability, geo-replication, multiple write locations, automatic and transparent shard management, transparent replication between operational and analytical stores, and much more. The Cassandra API stores data in a column-oriented schema. Apache Cassandra offers a highly distributed, horizontally scaling approach to storing large volumes of data while offering a flexible approach to a column-oriented schema. Cassandra API in Azure Cosmos DB aligns with this philosophy to approaching distributed NoSQL databases. The Cassandra API via protocol is compatible with the Apache Cassandra. You can use the Apache Cassandra client drivers to connect to the Cassandra API. The Cassandra API enables you to interact with data using the Cassandra query language and tools like the Cassandra query language shell and the Cassandra client drivers that you are already familiar with. The Cassandra API currently only supports the OLTP scenarios. Using Cassandra API, you can use the unique features of the Azure Cosmos DB, such as the change feed. You should consider using the Cassandra API if you want to benefit the elasticity and fully managed nature of the Azure Cosmos DB, and also still use most of the native Apache Cassandra features, the tools, and the ecosystem. This means that on Cassandra API, you really don't need to manage the operating system, the Java, the virtual machine, the garbage collector, the read-write performance, the nodes, the clusters, and so on. The Gremlin API allows users to make graph queries and store data as edge and vertices. The Gremlin API combines the power of the graph database algorithms with highly scalable, managed infrastructure. It also provides a unique, flexible solution to most common data problems that are associated with lack of flexibility and relational approach. The Azure Cosmos DB Gremlin API is based on the Apache Tinkerpop Graph Computing Framework, and it uses the same graph query language to ingest and query data. The Gremlin API uses the Azure Cosmos DB partition strategy to do the read-write operations from the graph database engine. The Gremlin API has a wire protocol support with the open source Gremlin, so you can use this open source Gremlin SDKs to build your application. The Azure Cosmos DB Gremlin API also works with the Apache Spark and Graph frameworks for complex analytical graph scenarios. You can use the Gremlin API for scenarios involving dynamic data, data with complex relations, data that is too complex to be modeled with relational databases, and if you want to use the existing Gremlin ecosystem and skills that you already have. The Table API stores data in key value formats. The Table API is best used for applications that are written for Azure Table Storage. They need premium capabilities like the turnkey global distribution, dedicated throughput worldwide using provision throughput, single-digit millisecond latencies at the 99th percentile, guaranteed high availability, automatic secondary indexing. The Table API only supports OLTP scenarios. OLTP stands for Online Transactional Processing, which is a type of data processing that consists of executing a number of transactions occurring concurrently. The OLTP examples can include online banking, shopping, order entry, or sending text messages. Applications written for Azure Table Storage can migrate to the Table API with little code changes and can take advantage of the premium capabilities. Let's take a look at some considerations when choosing an API. All the APIs offer automatic scaling of storage and throughput, flexibility, and performance guarantees. There is no one best API, and you may choose any one of the APIs to build your applications. The core SQL API is native to the Azure Cosmos DB. The API for MongoDB, Cassandra, Gremlin, and Table implement the wire protocol of open source database engines. These APIs are best suited if the following conditions are true: if you have existing MongoDB, Cassandra, or Gremlin applications, if you don't want to rewrite your entire data access layer, if you want to use the open source developer ecosystem, client drivers, expertise, and resources for your database, if you want to use the Azure Cosmos DB key features, such as the global distribution, elastic scaling of storage and throughput, performance, low latency, the ability to run transactional and analytical workload, and to use a fully managed platform. Also, if you are developing modernized apps on a multi-cloud environment. So based on your workload, you must choose the API that fits your requirement. The following image shows a flowchart on how to choose the right API when building new apps or migrating existing apps to the Azure Cosmos DB. Hello and welcome to this video. In this video, I'm going to sign up for a free Azure Cosmos DB account. Before you sign up for a free trial on the Azure Cosmos DB, you need an account on either Microsoft or GitHub. You also need to have an Azure portal subscription, which could be free or paid. The link for the free trial to the Azure Cosmos DB is displayed on the screen. This is the web page to sign up for a free trial on the Azure Cosmos DB. So I'm going to select the core, which is the recommended, and click on the link that says select. You need to sign in with your Microsoft or GitHub account. So I'm going to click on the sign in button. I'm going to click on my username here. I'm going to enter my password. Once your account has been created, you get a congratulations message saying that your Cosmos DB sandbox account is now ready for use in Azure portal. So you can open it in the Azure portal by clicking on this opening portal button. There's an option here to upgrade your account from the free version using this upgrade link. And you can also delete your free Cosmos DB account. The duration of the free trial is for 30 days. So you can see a message here saying I have 29 days left. Hello and welcome to this video. In this video, I'm going to create an Azure Cosmos DB account on the Azure portal. I've signed in to my Azure portal account. So from the home menu, I'm going to scroll down. On the Azure services, I'm going to click on this button to create a resource. There are several resources you can create. You can also search for your resource in the search bar. But the resource I want is listed here, which is the Azure Cosmos DB. So I'm going to click on it. The Azure Cosmos DB has several APIs, but I'm going to use the core SQL, which is the recommended API. So I'm going to click on the create button. So these are the steps that I'm going to go through to create an Azure Cosmos DB account for the core SQL API. So we're starting with the basics option. So for the project details, the subscription is already pre-populated. So I'm going to leave it like that. Next, I need to specify a resource group. Anywhere you have the red asterisks, those are mandatory fields that you need to populate. So I've already got some resource group. So you can either use your pre-existing resource groups or you can create a new one. So I'm going to create a new one. So I'm going to click to create a new one and I'm going to give it a name. I'm going to call my new resource group BLS NoSQL. You can see I've got a green tick, which means that name is available. So I'll click OK. I can see that name has been added to the resource group. I also need to give the account name for this resource group. I've provided an account name. I've called my account name BLS NoSQL admin. And then the location, the default location selected for me is US, West US. So I can change that by clicking on the drop down here and then select any region I want. But I'm going to keep it simple. I'm just going to accept the default location. For the capacity mode, I'm going to leave it on the default option. I'm going to progress to the second stage of the account creation, which is the global distribution. So I'm going to scroll down to the bottom of the page and click on the next button to go to global distribution. For the global distribution tab, I'm going to accept all the default settings and click on next to go to the networking tab. On the networking tab, you can connect to your Cosmos DB account either publicly via a public IP address or service endpoints, or privately also using a private endpoint. So there are different connectivity methods listed here. I'm going to accept the default, which is all networks, and click on the button to go to the next tab, which is the backup policy. So I'll click next. For the backup policy, you can configure it either periodic or continuous. I'm going to accept the default configuration, which is periodic. That means the backup is taken at periodic intervals based on your configuration. So again, you can play around with these configuration settings, but I'm going to accept the default settings and click on the next button to go to the encryption tab. So I'll click next. For the encryption, you can use the service managed key, which is the default, or the customer managed key. I'm going to accept the default setting, which is the service managed key. I'm going to progress to the next tab, which is tags, by clicking on the next button here. So tags are basically name value pairs that enable you to categorize resources and view consolidated billing by applying the same tag to multiple resources and resource groups. So if you want to learn more about tags, you can click on this link here, but I'm going to skip this stage and just go to the final stage, which is the review plus create. So I'm going to click on the review plus create tab here. You can see here my validation has been successful. I get a green tick, which means that I'm ready to create the account. So this page enables me to review the information that have been supplied. I have reviewed my account settings and I'm happy with all the setting information. So I'm going to click on this create button to create the account. It tells me the deployment is in progress. So we'll give it a few minutes to complete the deployment. When the deployment has been completed, you should get a message saying your deployment is complete and you should see the green tick. To see the resource that was created, click on the button that says go to resource. So this is the resource page and we can see it says congratulations, your Azure Cosmos DB account was created. Hello and welcome to this video. In this video, I'm going to add a database and a container to the Azure Cosmos DB resource on the Azure portal. In Azure Cosmos DB, the data is stored in containers. You can use the Data Explorer in the Azure portal to create a database and a container. From the navigation area on the left of your Azure Cosmos DB account page, you can select the option for Data Explorer. So I'm going to click on it. From the Data Explorer window, select the option here to add a new container. On the right, we have the new container window. It gives you some information here telling you that with the free tier, you will get the first 1000 RUS and 25 gigabyte of storage in this account for free. If you exceed the free quota, you will be liable to a billable charge. Inside the new container window on the right, I'm going to add some information. For example, I'm going to specify a database ID. The database maximum RUs has already been populated, so that's the minimum, so I'm going to leave that as it is. If you exceed the free quota here, there's going to be a billable charge, so it gives you an estimated cost in this area here. I also have to enter a container ID. I've added some information for the database ID. I've given it to-do list as my database ID, and then for my container ID, I've given it a value of items, and then for the partition key, the default here is ID. I'm going to change that to category. I've changed the partition key to category. I'm not going to add a unique key or analytical store. I'm going to skip these two options. Unique keys basically lets you add a layer of data integrity to the database by ensuring the uniqueness of one or more values per partition key. The analytical store is used to enable large-scale analytics against operational data without any impact to your transactional workload. So I'm going to skip the two options. I'm not going to add a unique key, and I'm not going to enable the analytical store. So I'm going to click on the OK button. The new database and container has been created, and we can see that being displayed in the Data Explorer window. Hello and welcome to this video. In this video, I'm going to add data to my database. In the Data Explorer window, I'm going to expand the to-do list database. I'm just going to click to expand the database. I'm going to expand the container, which is known as the items here. So I'll click to expand the items. And from the items container, I'm going to select items. And from the menu list here, I'm going to select the option here for new item. Your items can be added in this window here on the right. So it has automatically inserted an ID here for your item, but you can also replace the values. The structure of the data that's going to be added here is going to be in a JSON format. JSON stands for JavaScript Object Notation. So I'm going to add my own code here in this document window on the right. So I've added my own data here in the document window on the right. So it's in a JSON format. Your documents can have any structure because Azure Cosmos DB doesn't really impose any schema on your data. So let me go through the structure of my document. I've given it an ID, and the value of the ID is 1, so it has to be unique. When you structure your data in a JSON format, it's kind of like a key and a value representation. So the key is on the right, which is in red, and the value is on the right, which is in blue. So every key should have a corresponding value. On line number 6, we have a key here that says is complete. So by default, it's going to be false because I've not actually performed the actual operation yet. So this value is set to false. To save the data, I'm going to click on the save icon above here, and that should save that data. So the data has been saved. I'm going to add 2 more documents. following the same steps as I did with the first one. I've added 3 documents to my container. So you can see here I have 3 document IDs, which has to be unique. So that's it for this video. In this video, I added some data to my database. Thanks for watching. Bye for now. Hello and welcome to this video. In this video, I'm going to query the data in my container. You can query your data using SQL from the Data Explorer window, so you can retrieve and also filter your data using SQL queries. At the top of the Items tab in the Data Explorer, we have a default query here, which is this one here that says select star from C. So basically what this query is saying is that it's going to retrieve and display all the documents from the container. So you can also edit this default query by clicking on this edit filter button. So you can add a query predicate to the default query here. So I want to order the data, that is, I want to filter the data that is returned by the query, so I can specify how I want the data to be filtered. You can click on the drop down here. I can select any of these options here to add to the default query. So I can select this one here. So this basically is going to order the query by the container underscore TS, and then we have DESC, basically means that it's going to sort or filter the result in a descending order. So the modified query is going to display the documents in descending order based on their timestamp. So I'm going to click to apply the filter. Because I told the query to filter by descending, if we take a look at this area here, we can see the data has been sorted in a descending order. So we have the ID 321. That's because I specified in the query that I want the result of the query to be filtered in a descending order based on their timestamp. That means whichever item was added last is going to be returned first.